Hello everyone, and thanks for watching Edupedia World videos. In this video, we'll discuss solutions to problems in paper 2 of the 2013 JEE Advanced Mathematics paper. So let's move on to question 41, the first question of the mathematics section. We are given that there is a function y such that dy by dx plus xy by x squared minus 1 is equal to x to the power 4 plus 2x by root of 1 minus x squared. So this is in the standard form y dash plus p of y is equal to q. And what do you do in this case? You multiply this whole equation by the integrating factor e to the power integral of p dx. So p is x by x squared minus 1, which means integral of p dx is integral of x by x squared minus 1 dx. Just multiply this by 2 and take half here. If we take x squared minus 1 is equal to t, 2x dx is equal to dt. So what we get is half of ln of x squared minus 1, the integral of 1 by x. Right, and obviously we can add plus c as well. C will actually cancel out, so it won't make much of a difference. What is e to the power integral p dx then? It is e to the power of half ln x squared minus 1 plus c. Right, so half of ln x squared minus 1 plus half of c, we'll just write it as another constant c. And notice that if you multiply both sides of this equation, then this is e to the power half ln x squared minus 1 into e to the power of c, and e to the power of c will cancel from both sides, so it won't matter. The rest of the term we have put, so then we can write the LHS in a neater form. So we will now write it as e to the power, and this is half of ln x squared minus 1 is ln of root of x squared minus 1. Or rather, since it's given that it's between 1 and minus 1, all of these should be 1 minus x squared, because the domain of ln x is positive. Ln root of 1 minus x squared, which is root of 1 minus x squared. So root of 1 minus x squared is the integrating factor. We multiply both sides of the equation by this integrating factor. What we'll get is root of 1 minus x squared dy by dx plus xy by root of 1 minus x squared. But there'll be minus sign here as well, because this is x squared minus 1, so we can write this as minus of 1 minus x squared, and we multiplied by root of 1 minus x squared, so there's a minus sign. What is this equal to? The RHS multiplied by root 1 minus x squared, that is simply x to the power 4 plus 2x. And the whole point of using this concept of integrating factor was to be able to write the LHS in the form d of root of 1 minus x squared times y by dx. See, what is this term? First it will be root 1 minus x squared times dy by dx. Then it will be y times the derivative of root 1 minus x squared. What will that be? Root 1 minus x squared is 1 minus x squared to the power half. So half times 1 minus x squared to the power minus 1 by 2 into minus 2x. So 2 and 2 will cancel. You'll be left with a minus x by root of 1 minus x squared, which is the second term. So the LHS indeed is d by dx of root 1 minus x squared y. This is x to the power 4 plus 2x. What that means is y root 1 minus x squared is equal to x to the power 5 by 5 plus x squared plus c. Right. And we are given that f of 0 is 0. So when you put x is equal to 0 here, you just get y is equal to c, and y is 0 itself. So you get c is equal to 0. Right. So the final equation which we get, I'll just rub all of it now. We are just left with y root 1 minus x squared is equal to this term. Y root of 1 minus x squared is equal to x to the power 5 by 5 plus x squared, that is the integral of 2x. Just to simplify it a little bit further, we can write y is equal to x to the power 5 plus 5x squared by 5 root of 1 minus x squared. And now in the question, we need to integrate it from minus root 3 by 2 to root 3 by 2. And when you have denominators of the form of root 1 minus x square, you can directly put x is equal to sine theta, dx is equal to cos theta, d theta. And obviously the limits will be sine theta is root 3 by 2 means theta is pi by 3. So we'll get the integral from minus pi by 3 to pi by 3 sine to the power 5 theta plus 5 sine squared theta by 5 root 1 minus x squared will be cos theta, dx is cos theta d theta, so the cos thetas will cancel and you just get d theta. Right. And now we need to be able to solve for this integral. Right. Now sine to the power 5 theta is an odd function because sine theta is an odd function. So whatever the value is in the right hand side of the origin, it will be the inverse of that in the left hand side, and minus pi by 3 to pi by 3 will have to give the integral 0. So the integral of sine to the power 5 theta from minus pi by 3 to pi by 3 is 0 because sine to the power 5 theta is an odd function. So we are left with integral of minus pi by 3 to pi by 3 sine square theta d theta. Well, you know what we do here. This is half, this is 2, which becomes half of integral minus pi by 3 to pi by 3. 2 sine square theta can be written as 1 minus cos 2 theta. So it becomes d theta obviously. Half of the integral of 1 is theta and the integral of cos 2 theta is sine 2 theta by 2. And this is from minus pi by 3 to pi by 3. These are the limits now. So what is the value? Pi by 3 minus pi by 3 will be 2 pi by 3. Half of that will be pi by 3. So the first term is pi by 3 minus. Now this term is a fourth of sine of pi by 3, sine of 2 pi by 3 minus sine of minus 2 pi by 3, which is 2 sine 2 pi by 3, which is 2 into sine pi by 3 root 3 by 2 or root 3. So root 3. So the final answer is pi by 3 minus root 3 by 4, which means the answer to this question is option B. Let's move on to 42. Now in 42, I can't see a rigorous way to solve it. The best possible way I can think of is by looking at the options. You are given pi by 4 to pi by 2 cosec x to the power 17 dx. Now here's the thing. In the options, in all four options, I can see e to the power u plus e to the power minus u or e to the power u minus e to the power minus u. And the limits go from 0 to log of 1 plus root 2. So this is purely by hit and trial and by looking at the options. If you ask me how I got this, I won't be able to tell you. But I can see that you'll get something similar to the options if you put 2 cosec x is equal to e to the power u plus e to the power minus u. You could actually put it as e to the power u minus e to the power minus u as well. But now we'll see that the limits have to be the same as well. Right. So in this case, if x is pi by 4, cosec x is root 2. Right. So 2 cosec x is 2 root 2. So if you have the equation 2 root 2 is equal to e to the power u plus e to the power minus u. Let's just take for a second e to the power u to be x or to be y. So we get y plus 1 by y is equal to 2 root 2, which means y square minus 2 root 2 y plus 1 is equal to 0, which means y is equal to 2 root 2 plus minus root of 8 minus 4 by 2, which means y is equal to root 2 plus minus, this is root of 4, so 2 by 1, which is, sorry, 2, this is 2 which will be divided by 2, so this will be 1 as well, So it will be root 2 plus minus 1, right? Which means we can see that one of the terms root 2 plus 1 indeed becomes e to the power u, which means u is ln of 1 plus root 2. So what we get is pi by 4, the limit pi by 4 goes to the limit of ln 1 plus root 2. Similarly, what does pi by 2 go to? If x is pi by 2, sin x is 0, sin x is 1, cosec x is 1, so you get 2 is equal to e to the power u plus e to the power minus u, or y plus 1 by y, which means y square minus 2y plus 1 is equal to 0, which means y minus 1 whole squared is equal to 0, which means y is equal to 1, which means e to the power u is equal to 1, which means u is equal to 0. So pi by 2 goes to 0. I just wanted to show you this because all four options have the limits going from 0 to log of 1 plus root 2. And you would not have gotten these limits if you took e to the power u minus e to the power minus u, which is also two of the options. So that's the only way I can tell you how to proceed. You look at the options and you see that if you make this substitution, then not only does the function come out to be one of the options, but the limits come out to be the ones given in all the options as well. So we do this and now we proceed from here. So I'll just rub the rest of the part. And so now we simply have, this is the integral of pi by 4 went to ln of 1 plus root 2, and pi by 2 went to 0. 2 cosec x to the power 17 is simply e to the power u plus e to the power minus u to the power of 17. And what is dx? So from this equation we can get the value of dx as well, 2. Now the derivative of cosec x is minus cosec x cot x. So minus 2 cosec x cot x is equal to e to the power u minus e to the power minus u. Right, minus cosec x cot x dx, sorry, is equal to e to the power u minus e to the power minus u du. Right, and now we can just put in the values here. Minus 2 times cosec x, or rather minus times 2 cosec x is e to the power u plus e to the power minus u. Cot x dx is equal to e to the power u minus e to the power minus u du. So this term is cot x. We need to find the value of cot x. We know cosec square x minus cot square x is equal to 1, which means cot square x is equal to cosec square x minus 1, which is equal to e to the power 2u plus e to the power minus 2u, and you add these two. This is 2 into e to the power u into e to the power minus u, that is plus 2 minus 1, so you can just write it as minus 1. So cot square x is e to the power u plus e to the power 2u minus 1. Hang on, I made a mistake of 2 here. So cosec x is this by 2. So cosec square x will be this by 4. I'm sorry, plus 2. So this by 4, and there will be a minus 1 here, which is equal to e to the power 2u plus e to the power minus 2u. So this will be minus 4. That means this is minus 2 divided by 4. I forgot this factor of 2, which is equal to e to the power u minus e to the power minus u whole squared by 2. Which means basically cosec x, cot x comes out to be e to the power u minus e to the power minus u by 2. Right. So this term cancels with this term, and what you are left with is d e to the power u plus e to the power minus u dx is equal to minus 2 du. So this integral now becomes integral of, now minus 2 du, so the minus will just take in reversing the limits, so it will be 0 to ln of 1 plus root 2, and now dx is equal to 2 du. So 2 du times e to the power u plus e to the power minus u And now this is to the power 16 because dx into e to the power u plus e to the power minus u is 2 du. So only 16 is left. Right. And this is the same as option A. So the answer to this question is option A. Again, I repeat, all of this was pretty simple once you know that this is what you need to do to proceed. How did I know that this is what I needed to do to proceed? I can only tell you that that was done by hit and trial. I saw the options and I saw that we needed to do something like this. Either this or minus this, and if you did it with plus, you got the perfect limits. Right. Let's do question 43 now. The coefficient of x to the power 11 in the expansion 1 plus x squared whole to the power 4, 1 plus x cubed whole to the power 7, 1 plus x to the power 4 whole to the power 12. Right. So let's just look at what terms will be here. In this, the terms we get is 1, x squared, x to the power 4, x to the power 6, x to the power 8. With whatever coefficient, right? We know what the coefficients are. In this, we'll get 1, x cubed, x to the power 6, x to the power 9, x to the power 12, x to the power 15, x to the power 18, and finally x to the power 21. I hope all of you understand where I get this from. This is just 1 plus t whole to the power x, the standard binomial theorem. This gives me 1 x to the power 4, x to the power 8, x to the power 12, up till x to the power 48. And we need the net coefficient of x to the power 11, which means the sum of these three should be x to the power 11. So now we'll have to do a little bit of analysis. So let's just write these as x to the power 0 for now. We need the sum of something in the first set plus something in the second set plus something in the third set to be equal to 11. And we'll try to get the number of combinations. So let's take x to the power 0 in the first two. That would mean we need x to the power 11 in the third, which we cannot get. So that's not possible. What if we take x to the power 0 and x to the power 3? Then you would need x to the power 8, which you do have. So x to the power 0, x to the power 3, x to the power 8. That is one way you can add these up. Now you can invert that. You can have x to the power 8, x to the power 3, x to the power 0. Actually, you know what? Just forget the second one for a second. Let's try to do it systematically. Right, so we'll start with the smallest. So we started with the smallest in the first two, and we saw we didn't have anything in the third one. Then we took the smallest in the first one, and the smallest after x to the power 0, the second one, we saw x to the power 8. What if we take x to the power 0 and x to the power 6? That would mean we need x to the power 5, which we do not have in this one. We take x to the power 0, x to the power 9. That would mean x to the power 2, which we do not have. So we cannot make it with anything further than this. Let's move on to what if we have x to the power 0 here and x to the power 0 here. Then we need x to the power 11 here, which we don't have. What if we take x to the power 0 here and x to the power 4 here? Then we need x to the power 7, which we don't have with this one. What if we take x to the power 0 here and x to the power 8 here? Then we need x to the power 3. So again we get x to the power 8, x to the power 3, x to the power 0. Now in this way you'll have to look at all of the combinations. So these are two combinations. There are two other combinations which you'll be able to find out. X to the power 2, x to the power 9 and x to the power 0. And also x to the power 4, x to the power 3, x to the power 4. Right. Now everything else you can try after a certain point. Let's say you go to 8 and 6, that is already exceeded 11. So you'll be able to know nothing higher than this will be able to give a sum of 11. So it will be somewhere in these terms, and then you can just use permutation and combination the way I did, and you'll see that we'll actually have 4 ways of getting this. What are the coefficient in each way? In the first case, it is 4c0 into 7c1. Because this is the 0th term, this is the first term, this is the third term, into 12c2. What is it in this case? This is x to the power 8, which is 1, 2, 3, 4, 5th term. Right. Since the first term is 4c0, the 5th term is 4c4. into x to the power 3, that is again in this one, that is 7c1, into x to the power 0 in this one, x to the power 0 in the first one, which would mean, so hang on, this is, in the first case we had 8 in the third one, in the second case we need to have 8 in the first one, which is 4c4, yes, then 7c1, then we needed 0, so we need 12c1, or 12c0, sorry. In this case, we have x squared. X squared is 4c1. Into, we have x to the power 9, which is this term, 0, 1, 2, 3. So 7c3 into, and then we have x to the power 0, which is again 12c0. And the fourth term, we have 4, which is 0, 1, 2. So 4c2 into 3, which is 0, 1. So 7c1. Into 4, which is 0, 1, so 12c1, sorry. So these are the four terms. You can calculate the value of each of the 4 terms, and then you can add them up. So from now it's simple enough. 4c0 gives me 4, into 7c1 gives me 7, into 12c2 gives me 12 into 11 by 2. So this is 6. 66 into 7 into 4. Sorry, 4c0 is just 1, 4c1 is 4, sorry, 4c0 is 1. So it's 66 into 7, which gives me 462. So this is the first one. In the second case, we have 4c4, which is 1, into 7c1, which is 7, into 12c0, which is 1. So we have plus 7. In this case, we have 4 into 7c3, that is 7 factorial by 4 factorial, 3 factorial, or 7 into 5 into 6 by 3 factorial, into 12c0, which is 1. So 3 factorial cancels with 6. This gives me 35 into 4, that is 140. And the last term gives me 4c2 is 4 factorial by 2 factorial, 2 factorial, or 4 into 3 by 2 factorial, into 7 into 12. 2 factorial cancels with 2. So 2 into 3, 6 into 7 into 12, which comes out to be 504. And if you add these 4 terms up, you will get 1113. So the answer is option C. Let's move on to question 45. Sorry, question 44. This was 43. Now we do 44. We are given a function capital Fx is equal to integral 0 to x squared f of root t dt, and we are given f of 0 is equal to 1, and we are given f dash of x is equal to f dash of x for all x between 0 and 2. So we can find f dash x from here quite easily. That will be f of root t, and root t is obviously x, so f of x into the derivative of this limit, which is 2x, minus f of x into the derivative of this limit, which is 0. So f dash of x is equal to fx into 2x. We are given that this is equal to f dash of x. Now let's just take fx is equal to y. So dy by dx is equal to 2xy, which means dy by y is equal to 2x dx, which means ln y is equal to x square plus c. And then we are given f of 0 is 1. So when x is 0 and y is 1, ln y is 0, so c is 0. So we get ln y is x squared, which means y is equal to e to the power x squared, which is f of x. So based on the information given in the question, we were actually able to calculate the value of f of x. And now all we need to do is calculate the value of capital F of 2. That means the integral of 0 to 4, because then x is equal to 2, so x square is 4, f of root t dt. So f of x is e to the power x square, f of root t will be e to the power t dt. So the integral is just e to the power t with limits 4 and 0. So e to the power 4 minus 1 is the answer, which means that the solution is option B. Question 45. We are given a common tangent to the circle x square plus y square is equal to 2 and the parabola y square is equal to 8x. Touch the circle at points P and Q and parabola at R and S. So let's draw the figure. The parabola will be something like this, and the circle is centered at the origin with radius root 2. So the circle will be something like this. And the tangents will go something like yeah, there we go. So the tangents will be something like this. Yeah, so this point is given to us to be P, Q, R and S. So we have two tangents and we need the area of the quadrilateral PQRS. So we know the standard equation for tangents for a circle and for a parabola. For a circle, it's y is equal to mx plus, and if this is a squared, then a root of 1 plus x squared. So root of 2 times 1 plus m squared, 1 plus m squared. This is the standard equation of a tangent on the circle. The standard equation of a tangent on a parabola is equal to mx plus a by m, where a is 2 here, so 2 by m. We are given that these two are exactly the same. Right, obviously there are two values of m, but for a particular value of m, these two are the same tangent, which means 2 times 1 plus m squared is equal to 2 by m whole squared or 4 by m squared, which means m squared times 1 plus m squared or m to the power 4 plus m squared is equal to 2, which means m to the power 4 plus m squared minus 2 is 0, m to the power 4 plus 2m squared minus m squared minus 2 is 0, m squared times m squared plus 2 minus 1 times m squared plus 2 is equal to 0. M squared cannot be minus 2, so we get two solutions. M is equal to plus minus 1. Right. And I'll just rub this part now. And now the problem is quite simple enough. You know the solutions to both, you know both of the equations. So one is y is equal to x plus m is 1, so root of this is 2, so x plus 2. And the other one is y is equal to, you'll get the same thing here by the way. The other one is minus x minus 2. Now you have the two equations, you just need to calculate these 4 points. Obviously this line is x plus 2, this is minus x minus 2. So y is equal to x plus 2 we'll do first. And the intersection of that with the circle, which is x squared plus y squared is 2. So it will be x squared plus 4x plus 4 is equal to 2, which means 2x squared plus 4x plus 4 is equal to 2, or plus 2 is 0, which means x squared plus 2x plus 1 is 0, x minus 1, x plus 1 whole square is 0, x is equal to minus 1. If x is minus 1, y is equal to 1, because y is equal to x plus 2, right? Or even from this question, this equation. So x is minus 1, y is 1. That is this point, minus 1 comma 1. Right. Now I'm not going to do it for the other one. You can just calculate it yourself and see this is minus 1 comma minus 1. We can just see that by symmetry also. Similarly, y is equal to x plus 2 goes to y square is equal to 8x. So x square plus 4x plus 4 is equal to 8x. X square minus 8x plus 4 is equal to 0. X minus 2 whole squared is equal to 0. X is equal to 2, which means y is equal to 4. So this point is 2 comma 4, and similarly this point will just be 2 comma minus 4. Right. So you can do it for y is equal to minus x minus 2 on yourself. And now we need to find the area of this quadrilateral. So that's simple geometry. Half the sum of parallel sides into the distance between them is the area of a trapezium. So half into the sum of parallel sides. This is minus 1. This is 1 and this is minus 1. So this whole side is 2. This is 4 and minus 4. So this whole side is 8. So 2 plus 8 is 10 into the distance between them. So So this x is minus 1, this x is 2. So the distance between them is 3, which means 5 into 3, which means 15. So the answer to question 45 is 15, which is option D. So option D is the answer to question 45. Let's do question 46 now. We are asked the number of solutions of the equation sin x plus 2 sin 2x minus sin 3x is equal to 3. Right. So first what we can do is we can add the first and third term. So we get 2 sin 2x plus, now we have the formula for sin c minus sin d. Right. So that is equal to 2 sin c minus d by 2 cos c plus d by 2. So x minus 3x is minus 2x by 2 is minus x. So we just put minus 2 sin x, and cos of c plus d by 2, that is cos of 2x. And this is equal to 3, which means sin 2x minus cos 2x sin x is equal to 3 by 2. Right. We can write this as 2 sin x cos x. So what we'll get is minus cos 2x sin x is equal to 3 by 2, which means sin x times 2 cos x minus cos 2x is equal to 3 by 2. Right, which is sin x times, now we'll just use the formula for cos 2x, which is 1 plus 2 cos square x. So we'll get minus 2 cos square x plus 2 cos x minus 1 is equal to 3 by 2. Now sin x is always between 1 and minus 1. So this other term has to be greater than 1 for this result to follow. Right, so let's just look at this term for a second. Let's say cos x is equal to t, which means the term in the bracket fx is minus 2t square plus 2t minus 1. F dash of x is minus 4t plus 2, which is 0 at t is equal to 1 by 2. F double dash x is minus 4, which is negative, which means this is a maxima at t is equal to half. So at t is equal to half, which is a possible value for cos theta, this bracket achieves its maximum value. What is that maximum value? Minus 2 into 1 by 4 plus 2 into 1 by 2 minus 1, which is minus 1 by 2 plus 1 minus 1, which is minus 1 by 2. So that's the maximum value of this function, minus 1 by 2. Right. So when this is minus 1 by 2, of course it's not 1 then, but even then we can see that it can never be equal to 3 by 2. This has a maximum value 1. So when this is 1, this should have been 3 by 2, which it is not. So the answer to this question is that there is no solution. So the answer is option D. Hang on, I reviewed this and I made a slight error here. Cos 2x is 2 cos square x minus 1. So this will be plus 1. So this will be plus 1. This won't change. This all will stay the same. This is plus 1. So this is actually 3 by 2. So it was my mistake. The maximum value in this bracket is actually 3 by 2. But then the thing is, if this is 3 by 2 and this is 1, this equation is satisfied. But they have to be satisfied for the same x. Any x for which this term is 3 by 2 has cos x as half. And if cos x is half, sin x cannot be 1. Right? That is why there is no solution. So the maximum value of this is 3 by 2. But when the value of this term is 3 by 2, the value of this term is smaller than 1. It is actually root 3 by 2. So again, the answer is still the same. The methodology is a little bit different. I made an error of a minus sign here. But the answer is still option D, which means that there is no solution. Let's do question 47 now. we have in a triangle the sum of two sides is x and the product is y. So let's just say a plus b is equal to x and ab is equal to y. And x square minus c square is equal to y is an equation that is given to us. Then the ratio of the in radius to the circumradius. So let's just look at this equation first. X is a plus b, so we'll have a square plus b squared plus 2ab minus c squared is equal to ab, which means a square plus b squared plus ab is equal to c squared. What does that tell us? We know c square is a square plus b square minus 2ab cos theta. So this tells us minus 2 cos of the angle C is equal to 1, which means cos C is equal to minus 1 by 2, which means C is equal to 120 degrees. So this is the one thing we found out. We need the ratio of the in radius to the circumradius. We know the formula for both of them. The in radius is simply delta by S, where delta is the area of the triangle, and the circumradius has many formulas of the form of a by 2 sine a, b by 2 sine b. We'll just use c by 2 sine c. So the ratio of the two of them will be delta by s into 2 sine c by c. Sine c we can directly put. Sine of 120 degrees is root 3 by 2, so 2 sine c will be root 3. So this is equal to root 3 delta by s into c. We can simplify this more as root 3 times delta. We can write as just half ab sine c, where sine c is again root 3 by 2, divided by s into c. S is a plus b plus c by 2 into c. What does this become? Root 3 into root 3 is 3 by 4, so we get 3ab by 4, but we multiplied by the 2 here, so we get 3ab by 2 c times a plus b plus c. This can be written as 3y by 2c times x plus y. 3y by 2c times x is a plus b plus c. 3y by 2c times x plus c, which means the answer to this question is option B. Let's move on to question 48. Now question 48 is a standard dearrangement problem. We know already the standard formula for the number of ways to dearrange a system of 6 quantities. The number of ways will be 6 factorial times 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial plus 1 by 6 factorial. We already know this formula, right? This is the standard formula. I'll not derive it. And if you put this into the answer, what you get is 1 minus 1 factorial will just cancel. 6 factorial is equal to 6 into 5 into 4 into 6. So 36 into 20, that is 720. 720 by 2 factorial will be 360. Minus 720 by 3 factorial will be 120, because 3 factorial is 6, plus 720 by 4 factorial is 6 into 5, which is 30, minus 720 by 5 factorial is 6 plus 1. So what does this give us? 360 minus 120 is 240 and 30 is 270, minus 5 is 265. So 265 is the total number of ways to dearrange this complete system, which means to put them into envelopes such that no card matches its envelope. But we are given another condition, that the card 1 is always placed in the envelope 2. Now if you have envelopes 1, 2, 3, 4, 5, 6 and you dearrange it, then 1 can go into either 2, 3, 4, 5 or 6. It can't go back into 1. So it has 5 possibilities. One of those 5 possibilities says that it goes into 2. So out of these 265, only 265 divided by 5 will be the one in which it goes to 2. The same number will have it go to 3, 4, 5 or 6. So that gives me the answer to be 53. So the answer to this problem is 53, which is option C. Let's do question 49, which is also a permutation combination problem. We have three boys and two girls in a queue, and we need the probability that the number of boys ahead of every girl is at least one more than the number of girls. So we just put the three boys in a row, and we can put the two girls in different positions, and we'll see which one of them satisfies it. If both the girls are here in the beginning, but the number of boys in front of the second girl is 3, and the number of girls in front of the second girl is 1. So 3 is at least greater than 1 more than 1. So the equation is satisfied. And for this G, the girl in front, you have 3 boys and you have 0 girls. So for that also the equation is satisfied. So this is a valid arrangement. Then what if you were to have G here and G here? Then this girl has 3 boys and 1 girl in front of her, that is satisfied. She has 2 boys and 0 girls in front of her, which is also satisfied. So this is also valid. Now, what if you were to put both the girls here? Then the girl in the front would have 2 boys in front of her and 0 girls, which is valid. The girl behind her would have 2 boys and 1 girl in front of her. And the condition says that the number of boys is at least 1 more than the number of girls. So this girl has 2 boys and 1 girl in front of her, which is valid. So this is also a valid arrangement. What if you were to have 1 girl here and 1 girl in the front? Then this girl has 1 boy and 0 girls in front of her. She has 2 boys and 1 girl in front of her. So for that also the arrangement is satisfied. Right. What if you put both of them here? Then the girl in front has 1 boy and 0 girls in front of her, which is valid. But the girl who's behind has 1 boy and 1 girl in front of her, which does not meet our conditions. So this is not valid. Right. There is one, you can just try all the permutations like this. There are not a lot of them. You can put both of them here, here or here. Those are 4 combinations. Then you have 2 places to put 4 of them. Those are a finite number of combinations. There is one more combination which will satisfy this result though, and that is this combination. The first girl here and the second girl here. So she has 1 boy and 0 girls in front of her. She has 3 boys and 1 girl in front of her. So this is also valid. So we have 5 possible arrangements which are valid. The total number of arrangements in which you can put 3 boys and 2 girls is 5 factorial. Right? That is 120. But what are the number of ways in which this would be satisfied? There are 5 ways, but in each way you can interchange the 2 girls or you can interchange the 3 boys. So 3 factorial into 2 factorial. And the probability will be this divided by 5 factorial, which is 120. So what we get is 120 divided by 5 is 24. So 6 into 2 by 24, that is 12 by 24, that is 1 by 2. So the answer to this problem is option A. You can put both of them here. You can put one here and the other here. You can put one here and the other here. You can't put one here and the other in front, because then she has 0 boys in front of her and 0 girls in front of her, which does not satisfy our condition. Right. So the answer is 1 by 2, which is option A. Let's do question 50 now. The quadratic equation px is equal to 0 has purely imaginary roots. Right. So obviously if px was of the form of ax square plus bx plus c is equal to 0, the roots would be minus b plus minus the root of something by 2a. This thing can be negative, which would give imaginary roots. Purely imaginary roots means the real part is 0. So b has to be 0. So p of x has to be of the form of ax squared plus c is 0. Right. And then we are asked what are the solutions of p of px. That means you put px back into this. So you have a times x squared. Now x is px now because we are looking at p of px. Px is ax squared plus c. Put that inside this. So ax squared plus c whole squared plus c, which gives me a square x to the power 4 plus 2a square x squared c plus ac squared plus c, and this is equal to 0. Right. Now we can just straight away write the solution to this question. X squared will be minus 2a square c plus minus root of d squared minus 4ac. That is the square of 2a square c, 4a to the power 4c squared minus 4 times ac. That is a square into this term. A square into ac square plus c divided by 2a square, which is minus 2a squared c plus minus root of this is ax squared whole square, so a square x to the power 4 multiplied by a as well, so this is a cube x to the power 4. So what you'll have here is, this is by 2a cube and this will also be a cube, right? So my mistake. So 4a to the power 4c square and this is 4a to the power 4c square, so they both cancel. You just get minus 4a cube c by 2a, and we know that a and c are positive, so we can tell that this is imaginary, which means x squared is imaginary, which means x has to be imaginary, but x cannot be purely imaginary, right? If it's purely imaginary, x square would be a negative number, right? So if x square is not a purely imaginary number but an imaginary number, x has to be an imaginary number with both real and imaginary parts. So the answer to this problem is option D. No real solutions and no purely imaginary solutions. The only solutions are imaginary solutions. Let's do question 51 now. So we are given 4 points P, Q, R and S, and there is a parabola, so we just draw the parabola first. Right, P, Q, R and S. So let's just take some random points. This is P. We are given PQ is a focal chord. So if this is the focus, A, 0, then this would be Q. K is the point 2a, 0. So this is K, and R is another point. And we are given that this is K. We are given that PK is parallel to QR. Right. So P is given to us as 80 squared, 280. Q. We know that PQ is a focal chord, and for a focal chord we have T1, T2 is equal to minus 1. That means for Q it will be minus 1 by T. So it will be A by T squared minus 2A by T. R is AR squared, 2AR, and S is AS squared, 2AS. So we need PK to be parallel to QR. So let's just write the slope of PK and the slope of QR and equate them. The slope is given as y2 minus y1 by x2 minus x1. So in the first case, PQ, let's take this to be y. So 2AT minus 0 divided by AT squared minus 2A. This is the slope of PK. That is equal to the slope of RQ. That will be equal to 2A times R. And this is minus 1 by T. So plus 1 by T divided by A 1 by, so we are doing R minus Q, sorry, so R will be first, so AR squared minus 1 by T squared. Right. So this is the equation we have. From that we can just cancel A and A in this direction. We can actually cancel A here as well, and we can just write this as R plus 1 by T into R minus 1 by T. So what we are just left is R minus 1 by T. And the equation we get at R minus 1 by T is equal to 2 times T square minus 2 by 2T. Right, we can cancel 2 as well actually. So T square minus 2 by T, which means R is T square minus 2 by T plus 1 by T, which is equal to T square minus 1 by T. So R is T square minus 1 by T, which means the answer is option D. Let's go to the next question based on the same comprehension. 52. We are given that ST is equal to 1 then where do the tangent at P and the normal at S meet? We know the standard formulas for tangent and normal in a parametric form. The tangent at P will be yt is equal to x plus at squared, and the normal at S will be y plus xs is equal to 2as plus as cube. I won't derive these are the standard formulas. We need the ordinate of the point where they meet. That means we need the y component of the point where they meet. Right, so we'll just eliminate x, that's all. So we get yt minus at squared, this is x. So this into s plus y is equal to 2as plus s cube. And we'll just write s as 1 by t everywhere, right? So first what we'll get is y plus yt into s is simply y, minus at square into s is simply minus at, is equal to 2a by t plus 1 by t cube. We'll just take at to this side, so we'll add plus at here, and this is 2y. So y is equal to a by t plus 1 by 2t cube plus at by 2. We just take the denominator to be 2t cube, and what do we get? This is 2at squared plus 1 plus at to the power 4. Sorry, this is as cube, 2as plus as cube, so we should have an a as well here. Yeah, that's what I was thinking about, a should come common. So this becomes, you just take a by 2t cube common. What you get is t to the power 4 plus 2t square plus 1, or t squared plus 1 whole squared. A by t cube times t squared plus 1 whole squared, which means the answer to this question is option B. Let's move on to question 53 now. We are given a function g, and the question 53 is we need to find its value at half. So g of half will just be, we put the value half in a, so limit h goes to 0 plus integral of h to 1 minus h t to the power minus a, which is minus half, 1 minus t to the power a minus 1, which is again minus half dt. This can be written as limit h goes to 0 plus h to 1 minus h 1 by root of t into 1 minus t, so t minus t squared dt. And this is the root of a rational function. We know what we need to do in those cases. It will be the inverse of a trigonometric function, and we'll need to make the perfect square in the denominator. So we need to look at how we do that. And you already know how to do that. I'll just explain it a little bit. We know that this has to be something minus something minus something square. So there has to be a constant here. We'll just say it's square minus t minus something squared, right? This is the form we want, because then we'll have a term of minus t squared. But what is the other term we'll have? Whatever this is, let's say it's alpha, so we'll have minus 2t alpha and minus 1, so we'll have plus 2t alpha, right? The reason I put a minus here is because t square and t have the opposite sign. So if there was some alpha here, then this would be t square minus 2t alpha, minus 2t alpha, plus 2t alpha, because minus is here and there's a minus sign. Plus 2t alpha will be t, which means alpha is half. So this is half. And now this is half, we are left with a minus 1 by 4, which we do not need here. So we'll add a plus 1 by 4 here, that is half whole square. So this is how you make the perfect square in this case. Right, now this is a standard integral. You already know what its value is. This will be sine inverse of something. So we'll have the limits h and 1 minus h, and the integral will have the value. This is root of a squared minus x squared, that form. So sine inverse of x by a. So sine inverse of t minus half by a, which is half, which you can multiply by 2, and you can just write it as 2t minus 1. right? And 2 will cancel, so sine inverse of 2t minus 1, which is sine inverse of 2 times 1 minus h minus 1 minus sine inverse of 2h minus 1, where h goes to 0. So this is sine inverse of 2 minus 1 is 1 minus 2h minus sine inverse of 2h minus 1. When h goes to 0, this is 1 and this is minus 1. So this is pi by 2 minus of minus pi by 2, which is pi. So the answer to this question is pi, which is option A. Now 54 is also this based on the same comprehension, and it is also a question based on limits. It's a little lengthy, the calculation goes a little long, but in this we have to find the value of g dash of half. So how do we do that? We know that this is equal to limit delta goes to 0, g of half plus delta minus g of half by delta. We already know the value of g of half, but we can just try to calculate this limit and see what value it ends up giving us. Right. So it will be a little bit lengthy. Let me just try to write it properly. This is limit h goes to 0 plus, with a limit delta going to 0, the integral from h to 1 minus h of, first we'll put g of half plus delta, that will be t to the power minus half minus delta 1 minus t to the power a minus 1 half plus delta minus 1 minus g of half, which will be t to the power minus half 1 minus t to the power half minus 1 divided by delta. So this can be written as limit h goes to 0 plus limit delta goes to 0 integral h to 1 minus h. We can take t to the power minus half and 1 minus t to the power minus half common, and what we'll get is, so t to the power minus half is common from both, t to the power minus delta is left. 1 minus t to the power minus half is common, so 1 minus t to the power delta is left, and this is minus half, so minus 1 divided by delta. We can just write this as 1 minus t by t whole to the power of delta. And you can just take this limit inside because this part does not depend on delta, and we know what this is. This is limit x goes to 0, a to the power x minus 1 by x, and we know what this limit is. It is ln of x, right? So from this what we get is limit h goes to 0 plus integral 1 minus h to h t to the power minus half 1 minus t to the power minus half ln of 1 minus t by t, which I can write as ln of 1 minus t minus ln of t dt. Now from this we don't need to calculate the value directly. We can see one thing. We know that integral of a to b f of x dx is symmetric under inversion between a and b. So this is equal to integral of a to b f of a plus b minus x dx. Right? So what is the sum of a and b here? 1 minus h and h. The sum is 1. So this function will be the same as this function in which x is replaced by 1 minus x. So you replace t by 1 minus t. This becomes 1 minus t to the power minus half. This becomes t to the power minus half. So this thing remains the same. And you have ln of 1 minus t, which is t, minus ln of 1 minus t. But this is just the negative of the original thing. So we have this integral is equal to the negative of this integral, which only means that the value of this integral is 0, which means the answer is D. I'll repeat. This is the integral we got, and we see that in this integral, if we replace t by 1 minus t by using this identity, a plus b is 1 in this case, you replace t by 1 minus t, you get the negative of this integral. So if this integral is I, you get that I is equal to minus I, which obviously means that I has to be 0. Right. So this completes question 54, whose answer is option D. Let's move on to question 55. 55 and 56 are based on permutation and combination, and there is no short way to do that. The best possible way to do it is just to calculate the number of cases. So you have box 1 in which you have the numbers 1, 2 and 3. You have the box 2 in which you have the numbers 1, 2, 3, 4 and 5. And you have the box 3 in which you have numbers 1, 2, 3, 4, 5, 6, 7. You take 1 from each, x1, x2 and x3, and we need their sum to be odd. So if we choose it from 1, then the card can have 3 values. It can be 1, or it can be 2, or it can be 3. We'll do each case separately. Assuming we picked out the number 1 from this, then 1 is already odd, and we need x1 plus x2 plus x3 to be odd. x1 is 1 which is already odd, so these two would have to have the sum which is even. Right. So what are the possibilities for that? If we pick 1 in 2, that means if we pick this, you know what, just for the sake of clarity for a few seconds, because it might get confusing, I'll just use box A, B and C. Right. I know it's given 1, 2 and 3 in the question, but it might be confusing. So we have 3 boxes A, B and C, apologies. And box A contains numbers 1, 2 and 3, box B contains 1, 2, 3, 4, 5, box C contains 1, 2, 3, 4, 5, 6, 7. So if we pick one card from each, box A can only give us either 1, 2 or 3. We'll do each case separately. So first we'll consider that box A gives us the number 1. Then this is 1, the sum is odd, that means XB plus XC has to be even. XB can be any one of these 5 numbers. If XB is 1, then their sum has to be even, so XC has to be odd, which means it can be 1, 3, 5 or 7. So there are 4 cases. Plus, now XB can be 2. If XB is 2, this also has to be even because the sum is even. So 2, 4 and 6, you have 3 values. Plus, if XB is 3, this should be odd, 4 possible values. If XB is 4, this should be even, so 3 possible values, 2, 4 and 6. And if XB is 5, it should be odd, so 4 possible values, which gives us a total of 12 plus 6, that is 18 values. So there are 18 possible ways in which if you choose x1 to xa to be 1, then xb plus xc will be even, which means the total sum will be odd. Let's say we took xa to be 2. Then 2 is even, so xb plus xc has to be odd. So if xb is 1, xc has to be even, 2, 4 or 6, 3 values. If xb is 2, xc has to be odd, 4 values. 3, 4 and 3, just like that, which gives us a total of 17 values. And if c is 3, there will be again a total of 18 values. I'll just show it to you once. If this is 3 and their sum is odd, that means the sum of b and c has to be even. B can take a value 1, which means c has to be 1, 3, 5 or 6. So 4 possible values. B can be 2, which means c can be 2, 4 or 6. So 3 values. So again we get this 4 plus 3 plus 4 plus 3 plus 4. That is 18 values. So the total possibilities of this happening are 18 plus 17 plus 18, which is 53. And the total possible combinations in any possible way are 3 into 5 into 7. 3 possibilities for this, 5 for this, 7 for this. So the probability is 53 by 3 into 5 into 7, which is 53 by 105. So the answer to this is B. Let's move on to 57 now. Sorry, that was 55. This is 56 now. I wrote 56 earlier, but that was 55. Now we are taking 56, in which the probability that x1, x2 and x3 are in arithmetic progression. Right. So what are the possibilities? x1 can be 1. Then you can either have 1, 1 and 1, which is arithmetic progression. You can have 1, 2, and if the first two are 1, 2, then this has to be 3. You can have 1, 3, then this has to be 5. you can have 1, 4, and if this is 1 and this is 4 and they're in arithmetic progression, this has to be 7. If you had 1 and 5, then you would need to have in this place 9. But the box C does not have the number 9. It only has 1 to 7. So this is not a possibility. So these are all the possibilities if we take XA to be 1. What if XA is 2? Then the other 2 can be 2. That's fine. 2, 3 will give us 4 here. 2, 4 will give us 5 here. And 2, 5 will give us 8 here. But 8 is not in XC. Right? It only has 1 to 7. So this will not happen. Similarly, XA can be 3. So you can have 3 here. So 3, 3, 3. 3, 4, 5. 3, 5, 7. And you cannot have 3, 6, 9. Now this is a total of 10 cases out of a total of 105 cases. So many students might take the answer to be 10 by 105, which is option B. But this is a tricky question because there is one more case and the answer is 11 by 105, which is C. Yeah. And this one case, which some students might forget, is 3, 2, 1. Because it can be arithmetic progression with a negative difference. Right? It can't be that way too. If you have 2 and 1, then you would have to have 0. But 0 is not in any of them. So this is also one possible arithmetic progression where you take XA to be 3, XB to be 2 and XC to be 1. So there are a total of 11 possible cases, which is option C. I'm sure in this question many students would have marked option B for getting this particular case. Now we move on to match the following type questions, starting with 57. In which we are given a set of complex numbers zk equal to cos of 2k pi by 10 plus iota times sine of 2k pi by 10, which can also be written as e to the power iota 2k pi by 10, and k is between 1 and 9. So let's plot the graph first. We know what these are. If k is 1, this is e to the power iota pi by 5. That means at an angle of pi by 5 degrees. Then you have 4 pi by 10 or 2 pi by 5. Then you have 6 pi by 10 or 3 pi by 5, which will go like this. Then you have 8 pi by 10 or 4 pi by 5. And then you have finally this one, which is k will take the value 5, so this will be 10 pi by 10, which will be e to the power iota pi. Then you'll have the inverses. You'll have this one, in which k will be 6. So you'll have 2 into 6 into pi by 10, 12 pi by 10. That is 6 pi by 5. You'll have 7 pi by 5. You'll have 8 pi by 5. And then you'll have 9 pi by 5. So this is Z1, this angle is pi by 5. And we just keep rotating it by pi by 5 or 2 pi by 10. This is Z2, this is Z3, Z4, Z5, Z6, Z7, Z8 and Z9. Right, the vertical axes are not part of this. And this would be Z10 or Z0 if we took k is equal to 0, but that is not part of the set. So let's look at all the options individually. P option says, for each Zk, there exists a Zj such that Zk Zj is equal to 1. That means their multiplication is 1. Right, so if you multiply them and they have the same modulus, that means the angle will add up. Take Z1. You need to multiply Z1 by something so that it will give you 1. Well, if you multiply this by this whole angle, which is 2 pi minus pi by 5, or you can also take this to be minus pi by 5, then their product will be 1. We know Z1 Z9 is equal to 1. Similarly, Z2 into Z8 will be 1, Z3 into Z7 will be 1, Z4 into Z6 will be 1, and Z5 into Z5 will be 1. So P is indeed true for every Z. Now Z5 dot Z5 can be, because it's not given that that J has to be equal to K, right? So P is true, and if P is true, then Q has to be false because it is the opposite of P. There exists a K between 1 and 9 such that Z1 dot Z is equal to Zk has no solution, right? Because if Z1 dot Z was Zk, then Z would be zk by z1, or the difference between the two angles. And for any one of these, the difference between the two angles is a complex number, right? So P is true, Q is false. Let's look at R and S. Now, for looking at R and S, we can just start from the very basic definition of Z. We can see what these 9 numbers are. They are the 10th cube roots of unity. We can see that these 9 numbers, along with this, which for now I'll just call Z0, which is 1, these 10 numbers follow the equation Z to the power 10 is equal to 1. Right? Take pi by 5, multiply by 10, you get 2 pi. Right? Just like you have 1 omega omega square, the cube roots of unity, you have 1 Z, Z1, Z2 till Z9, which are the 10 tenths roots of unity. Right? So from Z to the power 10 is equal to 1. You get the solution to the equation Z to the power 10 minus 1 is 0 will be Z minus 1, Z minus Z1, Z minus Z2. These will all be multiplied, right? Z minus Z3 and so on. If Z is 1 or Z1 or Z2 or Z3, then right hand side will be 0 and Z to the power 10 is 1, so the left hand side is 0. Right, we can take Z minus 1 here. What we are left is Z to the power 10 minus 1 by Z minus 1 is equal to Z minus Z1 into Z minus Z2 into dot dot dot. Now what is this? We already know as an algebraic quantity what this is. We can write this as 1 plus Z squared plus dot 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 till Z to the power 9. This is equal to Z minus Z1, Z minus Z2 dot dot dot. Right. Now this is valid for all Z. So what we can do is we can just put Z is equal to 1. So the LHS will give me 10 and the RHS will give me 1 minus Z1, 1 minus Z2 dot 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 1 minus Z9. So from that we can see that the value of mod of 1 minus Z1, 1 minus Z2 and all divided by 10 is 1. So R is 1. That means R goes to 3. P goes to 1, Q goes to 2, R goes to 3. So S should go to 4 and the answer should be C. So we'll check out the value for S as well. Right. So it should come out to be 2. So S is 1 minus summation k is equal to 1 to 9 cos of 2 pi k by 10. So we already know 1 plus Z1 plus Z2 plus dot 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 till Z9 has to be equal to 0, right? These are the 10 cube roots, the 10th roots of unity, just like 1 plus omega square is 0, right? Even if, and you already know you can have the inverse of any one of them. If this was Z1, then this will be Z6, which will be the opposite, and if you add them, you'll get 0, right? So this means 1 plus cos 2 pi by 10 plus iota sine 2 pi by 10 plus cos 4 pi by 10 plus iota sine 4 pi by 10 and so on is 0. And you can just take the real part of this equation. What that will give you is 1 plus summation k is equal to 1 to 9 cos of k is equal to 1 to 9 cos of 2k pi by 10. This is equal to 0. That means this term summation 1 to 9 cos 2k pi by 10 is equal to minus 1. That means 1 minus of minus 1 is 2. So the answer to option S indeed is 2. The value of option S, the value of this quantity, does indeed come out to be 2. Let's move on to the second match the following, question 58. So we are given 4 completely independent options. Option P says that the number of polynomials with non-negative integer coefficients degree less than equal to 2. So the general form can be ax squared plus bx plus c. If degree is 2, a is non-zero. If a is 0 and b is non-zero, degree is 1. We are given that they satisfy f of 0 is 0. That immediately tells us c is 0. And 0 to 1 f of x is equal to 1, which means 0 to 1 ax square plus bx is equal to 1 dx, which means ax cubed by 3 plus bx squared by 2 from 0 to 1 is 1, which means a by 3 plus b by 2 is equal to 1, which means 2a plus 3b is equal to 6. Right, c is 0 and 2a plus 3b is 6. So, and you have to have non-integer coefficients. So the only possible values are a is 3 and b is 0, or a is 0 and b is 2. There are no other possible values of a and b satisfying this equation where a and b are non-negative integers. Right, if a is 0, then b has a value 2. If a is 1, then b is not a non-negative integer. If a is 2, b is not a non-negative integer. If a is 3, b is 0, and you can't have any other values. So the answer to option P is 2. That means P goes to 2. Now let's look at Q. In Q we are given the number of points between root 13 and minus root 13 satisfying the given equation, which is fx equals, now we are doing Q, so P went to 2, now Q, which is cos of x squared. Now keep in mind, this is not cos square x, this is cos of x squared plus sine of x squared. This is a maximum. That means f dash x has to be 0, which is, this would be minus sine x squared into 2x, this would be cos x squared into 2x. So 2x times cos of x squared minus sine of x squared. Let's just write f dash x also, because we'll need to know that it's a maximum, not just a critical point. 2 times cos x squared minus sine x squared plus 2x times derivative of this. So cos x squared will be minus sine x squared into 2x. Right, so we'll just take 2x common. So we'll just take 4x squared here minus sine x squared minus cos x squared, which is equal to 2 minus 4x squared times cos x squared minus 2 plus 2 plus 4x squared times sine x squared, right? So this is f dash x, f double dash x. Now we need f dash x to be equal to 0, which means either x is equal to 0 or cos x square is equal to sine x square, which means tan x squared is equal to 1, which means x squared is n pi plus pi by 4, where n is 0, 1, 2 and so on. So x is 0 or x squared is equal to pi by 4, 5 pi by 4, 9 pi by 4, 13 pi by 4, 17 pi by 4. But 17 pi by 4 now, and by the way, x square has to be positive, right? 17 pi by 4 goes beyond 13, and we know that x square cannot go beyond 13 because x is between minus root 13 and root 13. So we won't take this one, right? So there are 4 values of x squared here, and x can be 0. Now we need the maxima, so we need to put this back inside. Put this inside this. And if x is 0, this is 2 cos x square minus 2 sin x square, which is 2. So if x is 0, f double dash x is greater than 0, means it's a minima. And that doesn't work for us. We need it to be a maxima. Let's put down the values of these numbers within f double dash x. We've already seen that it's positive at x is equal to 0, but at any of these values, tan of x square is 1, which means that cos x square is equal to sin x square, which means that f dash x will just be 2 minus 4x squared cos x squared. We'll just take cos x square is equal to sin x squared. So minus 2 minus 4x squared cos x squared, which is 2 and 2 will cancel, minus 8x square cos of x square. So minus 8x square is always negative, but when is cos of x square or sin of x square negative? They are positive in these two cases because it's in the first quadrant, they are negative here. Right. So 5 pi by 4 and 13 pi by 4 are the two values for which cos of x square is negative. Oh, hang on, so we don't need negative. We need the total thing to be negative, so it to be positive. So pi by 4 and 9 pi by 4 are the two values where f double dash x is actually less than 0. Now x square is pi by 4 means x can be plus minus pi by 4. Two values plus minus 9 pi by 4. Two values. Therefore, there are a total of 4 values, which means that q goes to the number 4, which is the option 3. Right. So now let's look at R and S. So 0, 5 pi by 4 and 13 pi by 4 are actually minimas, and pi by 4 and 9 pi by 4 are the maximas, and that is the value of x squared. So we get 2 for each. Let's do option R. In option R, we are asked the value of integral of minus 2 to 2 3x squared by 1 plus e to the power x dx. Right. So first of all, this is an even function. If this was an odd function, the answer would directly be 0, but this is an even function, so we need to use some other method. Let's take this is equal to I. And an interesting thing we can see in these sorts of functions where you have 1 plus e to the power x in the denominator is if you take minus x is equal to t and minus dx is equal to dt, the integral I will become integral of 2 to minus 2. The limits will change. 3x square, this remains the same, by 1 plus e to the power minus x, which is 1 by e to the power x, and a minus dt. So minus, we can change the limits with minus, so it again goes from minus 2 to 2, and e to the power x goes upstairs, and we have the same thing multiplied by e to the power x. When we add these two, we get 2i is equal to integral of minus 2 to 2 3x squared times 1 plus e to the power x divided by 1 plus e to the power x, right, because this is e to the power x, so which is 1 dx, which is equal to minus 2 to 2 x cube, which is 8 minus of minus 8, which is 16. So 2i is 16, which means I is 8, which means R goes to the option 1. So it's 2, 3, 1, 4, which means option D is correct. But just for the sake of it, we'll look at option S as well. Now S, we can easily see that the numerator is odd, right? Because you have integral of minus half to half cos 2x ln of 1 plus x by 1 minus x dx. So you look at this term, x goes to minus x, this stays the same, but this becomes 1 minus x by 1 plus x, right? And we know ln of 1 by x is the negative of ln x, so it becomes the negative of ln 1 plus x by 1 minus x. So the numerator is odd, which means the integral of this has to be 0, which means S, it does indeed have to go to 4, consistent with the choice of option D. Let's do question 59. So this is again 4 independent questions. So option P says y is equal to cos of 3 cos inverse x, and x is between minus 1 and 1. Right. So if x is between minus 1 and 1, cos inverse x is between 0 and pi. So 3 cos inverse x is between 0 and 3 pi. But since this domain is the standard domain, we don't need to have to worry about any complications. We can just take x is equal to cos theta, which means cos inverse x is equal to theta. Right. And this is where it is used because x is between minus 1 and 1. Right. So cos theta will be 0 and pi. Right. So theta will be 0 and pi, sorry. And cos inverse x is theta. 3 cos inverse x is equal to 3 theta. Cos of 3 cos inverse x is cos 3 theta, which is 4 cos cube theta minus 3 cos theta, but cos theta is x, so this is 4x cubed minus 3x. So we figured out that y is equal to 4x cubed minus 3x. Now it's simple enough. Y dash is equal to 12x squared minus 3. Y double dash is equal to 24x. And we are asked to find the value of 1 by y, that is 1 by 4x cubed minus 3x. And this is why it's given to us that x is not plus minus root 2, otherwise this would become 0. Right. Yeah. So this is what is given to us, and the x square minus 1 into f double dash. So x squared minus 1 into f double dash, which is 24x, plus x into y dash, plus x times 12x squared minus 3, which is 1 by 4x cubed minus 3x times 24x cubed minus 24x plus 2x cubed minus 3x. Sorry, 12x cubed minus 3x. So the numerator is 36x cubed minus 27x by 4x cubed minus 3x, and we can see that this is equal to 9. The denominator doesn't become 0 because we are given x is not equal to plus minus root 3 by 2. So the answer to option P is 9, which means P goes to 4. Let's look at the other options. So we know P went to 4. Let's look at Q. So we are given that A1 to N are the vertices of a regular polygon. So let's just take a hexagon just for representation. And we are given summation k is equal to 1 to n minus 1, ak cross ak plus 1. That means a1 cross a2 plus a2 cross a3 plus dot 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 till an minus 1 cross an. The modulus of this is equal to the modulus of the dot products, a1 dot a2 plus a2 dot a3 plus dot 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 till an minus 1 dot n. Now the one good thing about this question is that we are already given that it's a regular polygon. In a regular polygon, all sides are the same, the angle between every two sides are the same. So a1 cross a2 will be the same as a6 cross a7 or whatever other value it will be. So we can just say that a1 mod of a1 cross a2 should be equal to mod of a1 dot a2. That's really all that matters. This is a1 and this is a2. Right, this is the angle between them. So which means mod a1 mod a2 sine theta equals mod a1 mod a2 cos theta, which means tan theta should be 1, which means theta should be pi by 4 for the minimum possible value. Right, if theta is pi by 4, this angle is pi by 4. You know what that means? This angle is 3 pi by 4, which means there are a total of 8 sides. Right, this is pi by 4, that means over n turns this will move on to n pi by 4, which should be 2 pi, which means n is equal to 8. So the minimum possible value of n is 8, which is option 3. So Q goes to option 3. Right. P to 4, Q to 3. Let's look at option R now. The normal from the point h, 1 on the ellipse x square plus y square, x square by 6 plus y square by 3 is equal to 1 is perpendicular to x plus y is equal to 8. This has the direction cosine I plus j cap. The vector perpendicular to this is I cap minus j cap, which has the slope minus 1. But the slope for the tangent of an ellipse at any point is given by minus x1 by 2y1 at x1, y1. We know this is equal to minus 1, which means x1 is 2y1, which means h, our x1, is equal to 2 because y is given to us to be 1. The point is h, 1. which means h has the value 2, which means r goes to 2, which means s should go to 1, and the final answer should be A. So we'll look at S now again. We should always check the fourth option as well in case we made a mistake. So let's now look at S. In S we are given that the number of positive solutions satisfying tan inverse of something plus tan inverse of something else is tan inverse of 2 by x squared. So I'll just directly use the formula for tan inverse A plus tan inverse B. We know what it is, tan inverse of A plus B by 1 minus tan A tan B. Right. So 1 by 2x plus 1 plus 1 by 4x plus 1 by 1 minus 1 by 2x plus 1, 4x plus 1. Which means 2x plus 1 plus 4x plus 1, that is 6x plus 2, divided by the product of this minus 1. So that will be 8x squared plus 2x plus 4x, that is plus 6x, and there will be a plus 1 minus 1. So this is all there is. This is equal to 2 by x squared. We can just cancel 2 directly. This is 3x plus 1, which gives us 3x cubed plus x squared is equal to 8x squared plus 6x. Or we'll take x common, right? So x is equal to 0 is a solution, but we are asked positive solution, so that won't matter. 3x squared, this is minus 7x squared, so minus 7x minus 6 is equal to 0. Now we can easily split the middle term here, and what we'll get is x times 3x squared. This is 6 into 3 is 18, which is 9 into 2, so we can write minus 9x plus 2x minus 6 is equal to 0, or x times 3x, x minus 3 plus 2, x minus 3. So x is equal to 0, x is equal to 3, and minus 2 by 3. So there is only one positive solution, x is equal to 3, which means that option S does indeed go to 1, as we would expect. Let's finally do the last question of this paper, question 60, in which we are given, so the first is f1x, which is mod x if x is less than 0, and e to the power x if x is greater than or equal to 0, and it is defined from R to R. For x less than 0, mod x can simply be replaced by minus x. So this is the first function. Let's just try to analyze this as much as we can right now. The graph for this function will be mod x or minus x will go like this for negative x, and e to the power x goes like this. So at x is equal to 0, it is 1, and it will go like this. Right. So we can see that this is neither continuous nor differentiable. So not continuous, not differentiable. This is not 1-to-1, because these two values of x give the same value of y, and it is also not onto, because the range is r, that is minus infinity to infinity, but it only takes positive values. So this is f1x. Let's do f2 of x now. That is simply x squared from 0, infinity to r. We know what the graph is. It's like this. So it's definitely continuous, differentiable. It is not 1-to-1 because these two have the same values, not 1-to-1. And it is also not onto, because the range is given to be r. If the range was given to be 0 to infinity, then it would be onto, but the range is given 0 to r, so it's not onto. Let's see f3 of x. f3 of x is sin x for x less than 0, x for x greater than or equal to 0, and it goes from r to r. So I'll just draw the graph right here. For x greater than 0 it is x. For x less than 0 it is sin x. So sin x goes like this. Right. Now the derivative at 0 for sin x will be cos x, which will be 1. Right. And the derivative here is 1. So it is continuous and differentiable. It is not 1 to 1 for these, because of these things. And the range is given 0 to r, but it does not take any value below -1. So it is not onto. And finally, let's look at f4 of x. That is given to be f2 of f1 of x if x is less than 0, and f2 of f1 of x minus 1 for x greater than or equal to 0. So we can just write what these values are. f1x we already know what it is. So this would be minus x would be f1x. We take f2x of that, that is square of that, so it will be x square. And here you'll have e to the power x, the square of that, so e to the power 2x, and then a minus 1. And the range of f4 is r goes to 0 to infinity. So let's draw the curve. This would be minus x square, and this would be e to the power 2x. So you take it down a little bit. This is e to the power 2x minus 1. They are definitely continuous. They are not 1 to 1. But they do go from 0 to infinity. They do take the value 0 as well. So they are onto. And what about differentiable? The derivative of this is 2x, which is a 0 at x. The derivative of this is 2 e to the power 2x, which is 2 at x, right? Because at x is equal to 0, both of them. 2 e to the power 2x at x is equal to 0 gives 2. So they are continuous but not differentiable. Right, so this is what we know up till now. Now let's look at the options. Option P is about f4. So we know f4 is neither f4 is onto but not 1 to 1. So option 1 is correct, and it is continuous but not differentiable, which is not any of the other options. Right, 2, 3 and 4 are all incorrect. So P goes to 1. Q, let's look at Q. Q is f3. f3 is continuous and differentiable. It is not 1 to 1 and it is not onto. So 1 is false. Neither continuous nor 1 to 1 is false. Differentiable but not 1 1 is true. Continuous and 1 1 is not true. So Q will be 3. R. R is f2 of f1, which is basically x square and e to the power x, not x square and e to the power x minus 1. So x square and e to the power x will neither be continuous nor differentiable. Right. And obviously it will also not be onto. Right. So f2 of f1 will be neither continuous nor 1 to 1. Right. So it is option 2. And S, which is f2. f2 is continuous, differentiable, not 1 to 1, not onto. Hang on, wait a second. It should come out to be 4, continuous, and 1 1. We said it's not 1 1. Okay, this is the mistake we made. Fx is going from 0 to infinity to r, right? If it went from r to r, then it would not be 1 1. But if you remove this part, if you only take this quadrant, then it actually is 1 1. Right, so it is 1 1 if you only take 0 from infinity to r. We took it from minus r to r, and therefore we said it's not 1 1. That was a mistake. So S comes out to be 4. It is continuous and it is 1 1. Right, it has to be continuous because it's not defined for x less than 0. So this is obviously continuous. So 1, 3, 2, 4, which means the answer to this question is option D. This completes the 2014 Mathematics JEE Paper 2. Thank you.